All right, this is section 1.6, inverse functions. So we are going to talk about inverse, exponential, and we're just going to talk about inverse functions, not exponential and logarithmic. So if you hear the word inverse, what do you think of? I tend to think of reverse, opposite, undo, and that's really the big idea. An inverse relation. If the ordered pair A, B is in a relation, then the ordered pair B, A is in the inverse. So if I tell you 3, -8 is in a function or relation, then that means in the inverse relation, -8, 3 is a point. Remember the vertical line test. Remember, if a vertical line crosses the graph of an equation at more than one point, then that equation is not a function. It was tested to see if you had a function. Now we're going to add the horizontal line test. The inverse of a relation is a function if, and only if, each horizontal line intersects the graph of the original relation and at most one point. So notice that it says a function, right? So it has to pass the vertical and horizontal line tests in order for the inverse to also be a function. So let's check. First off, check the vertical line test. A passes the vertical line test, so it is a function. Then we check the horizontal line test. It passes that as well, which means that A has an inverse that is a function. B, check the vertical line test. Ooh, we do not pass the vertical line test. So the original function, or the original equation, is not a function. Then we check the horizontal line test. And strangely enough, the inverse is a function. So the original is not a function. But the inverse is. Put some question marks there because that's crazy. For C, vertical line test to test if it's a function, it does not pass that. Horizontal line test to see if the inverse is a function, it does not pass that. Neither of those are going to be functions for us. And letter D, vertical line test to see if it's a function. Yes, it sure is a function. Horizontal line test to see if the inverse is a function, it fails immediately. So original is a function. Inverse is not. All right. So I just actually answered 2 questions in one. Sorry about that. I just wanted to know on this one if they were functions. So it was yes, no, no, yes. The next question asked if the inverse is a function, which was yes, yes, no, no. Sorry about that. All right, a function whose inverse is a function. It has a graph that passes both the vertical and horizontal line tests, such as graph A in that last one. That is considered one-to-one. One-to-one means every x is paired to a unique y, and every y is paired to a unique x. So in the rule to be a function, we said if I tell you what x is, I can definitely tell you what y is. Here, if I tell you what x is, you can tell me y. And if I tell you y, you can definitely, without a doubt, tell me what x was. So let's see if it's one-to-one. I have 4, -5, 6, 1, 2, 4, 0, -3. No x's go to more than one y. No y's are paired with more than one x. This is one-to-one. There are no repeated x's or y's. All right, 1, 0, 3, 0, 4, -5, 2, 3. So I look at my x's, and it's a function. Look at my y's, and I've got a repeat. If y is 0, x could have been 1 or 3. This is not one-to-one. Because y equals 0 is paired with 2x values. All right, let's decide if this is one-to-one. To tell if a graph is one-to-one, we use our line test. Vertical line test tells us if it's a function. This first one passes the vertical line test. Horizontal line test now would make it one-to-one. Uh-oh, fails the horizontal line test. This first one is not one-to-one because it fails the horizontal line test. Second one, check our vertical line test. And I know here in the middle it kind of looks like it's vertical, but it's actually not. It's getting really, really, really close and then really, really, really slowly far away. So it passes the vertical line test. Horizontal line test. We're good. It passes both. This one is indeed one-to-one. Passes vertical and horizontal line tests. All right, let's see if this one's one-to-one. So this one, let's check our vertical line test. We passed the vertical line test. Horizontal line test. Uh-oh. Nope, not one-to-one because it failed the horizontal line test. All right, so now inverse composition rule, and I apologize, my rule got a little wonky here. If a function is one-to-one with an inverse function if for every x. So our inverse function, I don't know what happened here, sorry about that. Our inverse function is going to be called g of x. Okay, that's our inverse function. So for every x in the domain of g of x, put this and somewhere else too, f of g of x equals x, and g of f of x equals x for every x in the domain of f. So if I do function composition with inverse functions, either way, it'll simplify to just x. That is how we know they are inverses. So let's see if these are inverses. We need to make sure we check both of them just to be safe. So let's start with f of g of x. That means I take f of x, which is x cubed plus 1. I leave out my x and I replace it with the cube root of x minus 1. And now I simplify. A cube root cubed undoes it, which means it's just x minus 1 plus 1, which is x. All right, now we have to try the other composition, which is g of f of x. I have the cube root of something minus 1. In that something, I have x cubed plus 1. All right, well, my plus 1 and minus 1 cancel, leaving me the cube root of x cubed, which is just x. They are indeed inverses then. All right, let's see if these two are inverses. This one gets a bit wonky. Let's start with m of n of x. It's 5 over something minus 2. That something is 2x plus 5 over x. All right. In order to simplify this, I need my denominator to have a common denominator. Right now this is a 2 over 1, so I'll need to multiply by x. So my 5 in the numerator is just hanging out. I have 2x plus 5 over x minus 2x over x. And when I combine those, remember my denominator of the denominator will just be x, 2x plus 5 minus 2x is just 5. Also remember that to divide by a fraction, I multiply by its reciprocal. So I'll multiply by x over 5. My 5's cancel, leaving just x. All right, now let's try n of m of x. This time I have 2 x's, so I leave out both of them. And I plug in m of x in both. So I have 5 over x minus 2 and 5 over x minus 2. All right, let's simplify that numerator first. I get 10 over x minus 2. Let's make that a 5 over 1. Let's multiply by x minus 2 and x minus 2 so that I have a common denominator in my numerator. That makes 5x minus 10 over x minus 2 over 5 over x minus 2. Combine my two fractions that are in the numerator. I end up with 5x over x minus 2 over 5 over x minus 2. And then we'll multiply by the reciprocal of the denominator. So we'll multiply by x minus 2 over 5. You'll notice my x minus 2's cancel, my 5's cancel, leaving just an x. Both compositions simplified to just x, so these are inverses. Now we're going to find an equation of an inverse from scratch. And there are some simple steps. For a one-to-one equation defined by y equals f of x, the equation of the inverse is found as follows. Replace your f of x or g of x or whatever it is with y. It's just easier that way. Interchange x and y. Switch all x's and y's with each other. Solve for this new y and replace that with our actual notation, which is f with a little -1 of x. That little negative got lost here. That's f inverse of x, not to be confused with a -1 exponent. So let's find our inverse. We start by changing f of x to y. Then we change all y's to x's and all x's to y's. So x equals 4y plus 3. Then we solve for y. So I'll subtract 3, giving me x minus 3 equals 4y. And I divide by 4, giving me x minus 3 over 4 equals y. Last step is to change that y to f inverse of x equals x minus 3 over 4. To check this, I plug this value in for x, and I plug this function in for this x. They will both simplify to just x. All right, this one's a little trickier. So we start by changing g of x to y. Then we switch all y's to x's and all x's to y's. So I get x equals y minus 2 over y plus 2. When you have something like this, there's a few tricks. First of all, I want to get rid of the fraction. So I'm going to multiply y plus 2 on both sides. That gets rid of my denominator. And I may or may not want to distribute on the left side. I think I'm going to. So x times y plus 2x equals y minus 2. Get all my y's on one side. So I'll subtract this y over. So if x times y minus y plus 2x equals -2. Get anything that doesn't have a y to the other side. So I'll subtract this 2x, leaving me x, y minus y equals -2x minus 2. Then we factor out a y from these two terms. That leaves me with x minus 1. And then I can divide by x minus 1, leaving me with y equals -2x minus 2 over x minus 1. So my inverse, which is g inverse of x, is -2x minus 2 over x minus 1. depending how you go about this, your answer could look slightly different and still be absolutely correct. So just be very careful, keep an eye on what your answer is, and if it could be simplified to this, or if this could be simplified to your answer. All right, let's find this inverse. Step 1, change f of x to y. Step 2, switch all x's and y's. So x equals 2y cubed minus 5. Now we solve for y. Add 5. So x plus 5 equals 2y cubed. Now you have to be very careful of your order of solving. We have to get rid of that 2 first before we undo the cube. So we have x plus 5 divided by 2 equals y cubed. And we want y completely by itself, so we are going to cube root both sides. So y equals the cube root of x plus 5 over 2. Now we change back our notation to f inverse of x, which is the cube root of x plus 5 over 2. And there's our answer. And now we will practice.